Right, another limit of a sequence example. So first, some notation in factorial. This is n times n minus 1, n minus 2. Keep doing that, multiplying by 1 less until you get down to 1. So 3 factorial is 3 times 2 times 1, 6. 4 factorial, 4 times 3 times 2 times 1. Notice that's just 3 factorial, 4 times 6 is 24. Okay. Okay, now we're going to investigate the limit of the sequence defined by an is 5 to the n over n factorial. Okay, so 5 to the n is exponential, so it grows pretty fast. But in factorial, you'll see it grows faster. All right. And kind of the interesting thing is that it doesn't grow faster right away. But remember, all we're concerned with is the tail. So if at first this grows faster than that, but eventually this grows faster than that, that's all that we really care about. And that's what we'll see happens. Okay, so here we've got 5 squared is 25. 25 times 5, you got 5 quarters in your pocket. That means you got 125, 625, 10. Let's see, we've got 9,765,625 at 15. These numbers start to get pretty big. We got 3.05 times 10 to the 10. That means moving this over 10 decimal places, it's a pretty big number. At 20, we got 9.5 times 10 to the 13. So move that decimal over 13 times. That's 95 with 12 zeros after it. Huge number. 50, 8.8 times 10 to the 34. Huge. Huge. I mean, just think. 88 with 33 zeros after it. That's like a really big number. Okay, so in factorial, this is 1. So this is 2 times 1, or 2. 3, let's see, that's 3 times 2 times 1, that's 6. 4, let's see, we found that to be 24. Okay, now at 10, what happens? What do we got at 10? We got 3,628,800. You can see that 5 to the n is still bigger at 10. But things start to change at 15. 15, we got 1.3 times 10 to the 12. Now, even though 1.3 is less than that, right, you can just think, okay, how many times are you going to move that decimal over? You're moving over 10 times there, you're moving over 12 times there. It's a little bit bigger. Here we got 2.4 times 10 to the 18. 18 is much bigger than 13, so much higher order of magnitude there. And now at 50, 3.04 times 10 to the 64. All right, now we're just huge. So much bigger than that thing. I mean, it's crazy, just crazy. Okay, so now we're gonna divide these, let's see. So here we get, so now we're putting that on top of that, right? So this is 12.5, 25 over 2, 12.5. Let's see, we got 20.83, 26.04, 2.69. Right, so think what's going on there, right? These are all bigger than 1. That means that the top is bigger, right? The top is bigger because these are all bigger than 1. But what happens, right? As soon as the bottom gets bigger, we get less than 1. 0.023, 1, 2, 3, 4, 1, 2, 3, 4, 3, 9. And here, I can't even write all the zeros. I gotta use scientific notation. Okay, so we can see here that as n gets large, the tail gets small, right? So, right, negative 30, that means we're going this way with zeros, right? So this is going to be 0.000000002.92. 29 zeros in there, right? So that's really small, just at 50, right? So the limit equals 0. Okay, now, because I have your attention, what happens here? Right, this thing just gets huge. This thing can't mess with that too much. So here we got infinity.